So we're going to continue our look into parabolas and their features. So we're going to look at some key features of functions this week. For the first one, we have this graph of y equals x squared. And I've already graphed it for you. So let's go in and fill in what these y coordinates are here based off of the points that have been given to us in the graph. So our first point at -2, what's the y value at -2? Well, that y value is 4. All right. And what's the y value at -1? Well, it's +1. The y value at 0 is 0. The y value at 1 is 1. And the y value at 2 is 4. Some vocabulary for us to know. The vertex of the parabola is this point where you see how our numbers repeat here. All right, well, the vertex is that right in the middle. So the vertex of the parabola is the point that has the symmetry between both sides of our parabola. This point, the vertex, okay, there's our vertex there. It just happens to be at the point 0, 0. This can be a maximum or a minimum. So a maximum is going to look like a mountain, and a minimum is going to look like a valley. All right. A blank happens when a graph goes from decreasing to increasing. So we talked about decreasing is going down, and then increasing is going up. So if it's down to up, all right, it's looking like a cup right there, right? Down to up. It's going to make this look like a cup, which will be a minimum. Okay, so the opposite's true. A blank happens when a graph goes from increasing to decreasing. So increasing to decreasing. Well, here we're going to have a mountain, and this is going to give us a max up here. Okay, so let's look at these points. So for the next graph of f of x at x equals -3, we have -3. At -2, it's 0. At -1, it's 1. At 0, it's also 0. And at 1, it is also -3. And so here, our maximum point is at the vertex, which is at -1, 1. Okay, the y-intercept and the x-intercept. So the y-intercept is when the graph crosses the y-axis here. And as you can see, that y-intercept is this point right here. That's at 0, 0. So where the graph touches the y-axis is our y-intercept. And the x-intercept, obviously, is where the graph touches the x-axis. So I'm going to do that in yellow, where is the x-axis. Well, here the y-intercept 0, 0 just happens to also be one of the x-intercepts. And this is our other x-intercept, which is the point -2, 0. All right, so let's find the features. So we have 3 graphs that are given to us, and we are asked a series of questions for these. All right, so which one has a range of 1 to infinity? Well, the range deals with our y values. So y values ranging from 1 all the way to infinity. And it looks like that both A and C have that. Okay, what about a domain of -infinity to infinity? Well, that looks like the x values, that deals with the domain, has to be all real numbers. So A is marked out because there are no negatives in this domain. So this is B and C. Which one has a minimum value? So going from decreasing to increasing at the point 0, -2. Well, this has a minimum value at 0, -2. But this has a minimum value at 0, +1. So the only one that works here is b. How about a domain from 1 to infinity? Well, since b and c have a domain of negative infinity to infinity, a is the only one to look at. Its domain goes from, well, not 1 to infinity. This domain goes from 0 to infinity. So we would say not any for this. And then which graph is always positive? Now remember, positive means that we are above the x-axis always. And you see B has some areas that go below the x-axis, but A always stays above the x-axis, and C always stays above the x-axis. Okay, the last things for us to talk about are even and odd functions. So even functions, you see some examples here. Even functions are symmetrical over the y-axis. So as you can see, all of these have perfect symmetry over that y-axis. And then odd functions have symmetry over the origin. So the origin point, they have symmetry through the origin. Okay, and we can also have a function that is neither. So it doesn't have symmetry over the y-axis, and it doesn't have symmetry through the origin. So this example, we would say that this